Today we're getting into the first thing we usually cover when we come to our unit on quadrilaterals, and that is parallelograms. A parallelogram is one of the most interesting quadrilaterals, and remember, quadrilateral just means four-sided figure. So a parallelogram is a special one in that it has the property of having opposite sides parallel. That's why it's called that. So here we have a four-sided figure, A, B, C, D. So it's a quadrilateral. If I specify that side AB is parallel to side DC, and I'm going to put these little arrows to indicate that, and also specify that AD is parallel to BC, now I know it's a parallelogram. And there are generally thought to be 5 properties that you could kind of describe some more things and maybe call them properties, but generally we think of there being 5 properties of parallelograms. One of them is the definition, which is what I just put on here. So the first one is, and this is something that's true in every parallelogram, opposite sides are parallel. This is really the defining characteristic. So this one could also be thought of as the definition of parallelogram, as well as being something that's true for all of them. Okay, so if we're including the definition, there are 5. If you take the definition and think of it as a separate thing, then there would be 4 main ones. These are very often, the 4 other properties of parallelograms are very often referred to as theorems. And here's a list of all of them. Here's a listing if you want to pause it and come back and look at that. But we're going to go through them one by one. So opposite sides are parallel. AD is parallel to BC, AB is parallel to DC. So we've got that there. It's interesting to point out at this point that if I wanted to, I could use what we already know about parallel lines that have a transversal crossing them. Like these are 2 parallel lines and this is a transversal, or these are 2 parallel lines and this is a transversal. I could use the properties of those angles, and I could also use congruent triangles by drawing a diagonal either here or here to prove everything else that I'm going to say about parallelograms. So all of this is provable, so to speak, which is why they're called theorems. So second thing we usually look at is that not only are the opposite sides parallel, but the opposite sides are congruent. Now when I say opposite sides in a generic way like that, I'm saying both pairs, not just one pair. Both pairs of opposite sides are congruent. So for instance, if I have a parallelogram, and I know that this side is 10, then that automatically tells me this side length is 10. If I know that this side length is 7, then so is this one. That's opposite sides being congruent. Next thing, we know that opposite angles are also congruent. Okay, so we have to figure out where are the opposite angles. And there are 2 pairs of them, just like there are 2 pairs of parallel sides, 2 pairs of congruent sides. Same thing with angles. Opposite angles would be the ones that are sort of diagonally across from each other. So this angle, angle ADC, would be congruent to this angle, angle ABC. Those 2 angles are congruent. Likewise, angle A, angle C. Or we could call it DAB and DCB. So that's my opposite angles being congruent. I don't really want to mark everything on the same picture. That's why I didn't mark that the opposite sides are congruent, but I could. Why not? Let's go ahead and remember, this is how we show that things are congruent in terms of lengths. So the arrows are about parallel and the little hash marks are about length. So now everything's marked on my picture. At this point, I'm probably going to start moving off the picture because I'm going to have too many things marked and run out of room. All right, we got 3 things down. That means we've got 2 things left to come. All right, the next thing is also about the angles, consecutive angles. And this word might remind you of consecutive interior angles, which is basically the same thing. Consecutive angles are, just like consecutive interior angles, are supplementary. So in other words, if I'm looking at any 2 angles in the I started to say triangle, in the parallelogram, that are one after another if I'm walking around it or walking around inside it. 2 that are next to each other or in a row. That's consecutive. So angle D and angle C are supplementary. That means they add up to 180. C and B are supplementary. These 2 add up to 180. B and A are supplementary. They add up to 180. And A and D are supplementary. They add up to 180. And there's not really a way to mark that, so that's kind of convenient because that means we don't have to put any more markings on there. Finally, we need to talk about the diagonals. The diagonals of a parallelogram bisect each other. Okay, so let's look down here at what that means. Diagonals bisect each other. Diagonals of a parallelogram. Any diagonal of any figure basically means you're taking 2 points that are not already connected by a side and connecting them. So that's a diagonal. This one matches our conception of a diagonal, which is basically, we like to think of diagonals as slanted on the page as opposed to horizontal or vertical. We think diagonal is slanted. That's not what it means though. Diagonal just means I'm connecting 2 non-consecutive vertices, or 2 vertices that aren't already in a row with each other around the outside of the figure. So this quadrilateral has diagonals QS and RT. Now if they bisect each other, let's just think about that one at a time. If QS bisects RT, that means QS cuts RT into 2 congruent pieces. So that means where QS crosses RT, it chops it into 2 congruent pieces. So for instance, if RT was originally 10, QS cuts it into 2 pieces that are 5 and 5. But this says each other, so it works both ways. RT does the exact same thing to QS. So RT cuts QS into 2 congruent pieces. So this is what it means that diagonals bisect each other. Notice that they don't have to be congruent to each other. Let's go back to that example. I said RT was 10, then this would be 5, and this would be 5. Let's say that maybe QS, the total length is 8. Then this would be 4, and this would be 4. So they don't have to be the same as each other. In some quadrilaterals they will be, but in just generic parallelograms they're not necessarily. They just bisect each other, which means the parts on either side of where they meet are congruent. Another way of looking at that is the point where they meet is the what of both segments. It's the midpoint. So this is the midpoint of QS, and this is the midpoint of RT. Let's go ahead and call it M since it's a midpoint. So M is right in the middle of QS and right in the middle of RT because the diagonals bisect each other. So there are my 5 properties of parallelograms. So let's look at some problems where we might be able to use those. Well, let's go ahead and look at this worksheet. Handy dandy worksheet. Choose a word from the bank to complete each sentence. Words will be used more than once. A quadrilateral with 2 pairs of parallel sides is a parallelogram. It's a great time to learn to spell it. The opposite sides of a parallelogram are congruent. That was my second property. My third property that I mentioned was that opposite angles are congruent. Consecutive angles of a parallelogram are, they're not congruent. Remember, those are the 2 in a row, like C and B, or B and A. They're supplementary. And finally, the diagonals of a parallelogram bisect each other. So that's just fill in the blank for our first 5 there were the properties. All right, use the parallelogram math, in other words, this parallelogram over here, M-A-T-H, to answer these questions. Name 2 pairs of congruent angles. Well, what kind of angles are congruent? Opposite angles. So angle H and angle A. So angle H is congruent to angle A. And angle M is congruent to angle T. All right, name 4 pairs of supplementary angles. Well, any 2 in a row. So H and T, T and A and M and H. And I would just really just say, I would do it the same way I just said it. H and T. There's not really room in here to write the measure of angle H plus the measure of angle T equals 180, which is how we could indicate that. All right, name two pairs of congruent segments. Well, we know that opposite sides are congruent. So I'm going to name one pair for you and let you name the other. MH is congruent to the side across from that, and that's AT. And you go ahead and do the other. Next, looking at number 9 here. Find the missing angles and sides. Label them on the pictures. Okay? Well, let's start with the side lengths. This tells me that OP is 6. And if this is a parallelogram, which we're pretty much having to assume here, they should have told me that in the directions, but we're going to have to assume it. If OP is 6, then I know that the opposite side is also 6 because opposite sides are congruent. If ON is 4, then I know that PQ is also 4 because opposite sides are congruent. So that's the missing sides. Now they also asked me to do the missing angles. If this is 32, notice that I only have one angle here, and I'm going to be able to find all 4. Because I know that across from it diagonally, that's the opposite angle, will also be 32. And I know that any two that are next to each other have to be supplementary. So what kind of angle would be, or what size angle would be supplementary to 32? Well, we subtract 180 minus 32, and we get 148. So these two other angles have to be 148. That way, 32 plus 148 is 180, 148 plus 32 is 180, 32 plus 148 is 180, and so on. And notice that opposite angles are still congruent here. Number 10 is exactly like the one we just did. I'm going to let you do number 10, and then you're going to look at your homework survey. There's going to be a place for you to put the answers to number 10 in that survey. So on your e-class, if you're in my class, go ahead and make sure that you see that homework survey and put that information in as well. Looking at number 11. Okay, let's see. We have, this is 2, it kind of looks like a Y to me. No, it's not. I'm sorry, it's a 4. It's 24 degrees. What do you know? All right, so I have triangle ABC here. Very often now, our previous knowledge is going to come into play. I know a triangle has 3 angles and that they add up to what? 180. So if I know that this is 24 and this is 15, 24 plus 15 is 39. So I can subtract 180 minus 39 to find the missing angle. And that's going to tell me that angle B is 141. If angle B is 141, then across from an opposite angle is right here. Now, how am I supposed to find these other two angles, though? Well, remember that opposite sides are parallel. That means I have alternate interior angles. Remember, alternate interior angles we think of sometimes as making sort of a Z shape, and it can be backwards. So the 24-degree angle right here, that's an alternate interior angle with this one up here, which is also going to be 24. And the same thing is true. Let's see if I can find another good color. Same thing is true because these two sides are parallel about the angle that is measured 15 and its alternate interior angle. So this angle right here is an alternate interior angle with this one down here. So this is 15. So now I found all my missing angles. They also want the missing sides because notice they gave me the side lengths. If CD is 12, so is AB. If AD is 13, so is BC. All right, number 12, we finally get into that whole diagonals bisect each other thing because FH is a diagonal and EG is a diagonal. Don't worry about the fact that this looks like a rectangle at this point because we don't necessarily know that. Right now, all we can see here is that, well, again, they should have told us we had a parallelogram here. We can see that the diagonals bisect each other. We can also see that they're congruent, but we really haven't discussed that yet, so let's not go anywhere with that. If this is 5, then this has to be 5 because the diagonals bisect each other. The reason I know they're congruent, though, is if I'm using exactly the same marking, that means exactly the same length. So this is 5 and this is 5. So my diagonals are actually congruent here. Now, let's look at the angles. Look at this. Let me label this middle point here so we can use it. I'm going to call it T. Look at triangle ETH. Triangle ETH is an isosceles triangle because it has two side lengths that are the same, the legs. Remember that if we have an isosceles triangle, then the base angles are the same. The two sides that are the same are the legs. The one side that's different is called the base, and it's the two angles at either end of that that have to also be the same. So this is 20. Okay, then I can find this angle here because I have a triangle and I know 2 out of 3 angles. 20 plus 20 is 40. 180 minus 40 is 140. Now let's come over and try to bring that into this triangle next to it. If this is 140, notice, and let me see if I can find something to put up against the edge of it to point it out. Notice that FH is a straight line, so this is a linear pair. The angle that's 140 and the angle next to it over here, that's a linear pair because FH makes a straight line, or a line period. Okay, so these two have to add up to 180. So if this is 140, this is 40. And I can go ahead and finish these because this is a vertical angle with the angle on top of it. And these two are vertical angles as well from side to side, so this is 40. So now let's look at this triangle. If this is 70 and this is 40, those two add up to 110. Subtract that from 180, and this is 70. We could have also used the fact that this is also an isosceles triangle. I can keep going all the way around, but what I'm going to find out is that this triangle over here and this triangle over here, well, they're the same triangle. If you look at the side markings and then the angle between them, that's by side angle side. So this is 70 and this is 70. Same thing, the triangle down here with the triangle up here. Side angle side tells me these two triangles are exactly the same. So this is actually a rectangle. We haven't talked about rectangles yet, but the reason I know it's a rectangle, other than by knowing something about the diagonals that we also haven't discussed, rectangles have 4 right angles. 70 plus 20 is 90. 20 plus 70 is 90. 20 plus 70 is 90. 70 plus 20 is 90. All right, let's look at number 13. If dx is 4, label it right away, and ax is 6, well, if this is a parallelogram, and they did tell me this time at least that it was, that my diagonals bisect each other. So if this is 4, this is 4. If this is 6, this is 6. So I've already answered bx, and what is that, xc? So how would I find BD? 4 plus 4. How about AC? 6 plus 6. All right, on the back. Number 14, if the measure of angle ABC is 120 degrees. ABC, that's this one out here, is 120. Sometimes it can help to draw just a part of what you've got. Like for instance, on this one. Those diagonals, there's just so much information in this, it kind of muddies the water a little bit. And I just drew diagonals again. I don't want to draw diagonal. Let's just look at the sort of outline of the parallelogram itself. If ABC is 120, well, that tells me this is 120, and these other two have to be supplementary to 120, so that's 60. So I can answer some of these questions a little bit more easily from this figure. And you need to feel free to redraw just a part of it, just whatever part you need to focus on. So ADC is 120. DAB is 60. Now angle 1, angle 2, angle 3, and angle 4, those all require the diagonals because they're cutting it into smaller pieces. Okay, so now I need to get into looking at the diagonals. Now, if this is 40, let's focus just on this triangle CXB. The reason I want to focus on it is because I know 2 of the angles already. If I know 2 angles, it's easy to find the third one. I just subtract from 180. So 50 and 40 adds up to 90. subtract from 180, and angle 2 here is also going to be 90. 90 plus 40 plus 50 equals 180. Now here's the thing, angle 2 is part of the big angle ABC. And we already know that that angle is 120. So if I know this whole angle here is 120 and this side is 90, I can subtract from 120 and get 30 for angle 3. Okay, there are multiple ways to look at this. The way I see finding angle 4 now, this is the next thing that occurs to me, is looking at triangle ABC. Excuse me, I lied. DAB. Look at that triangle, DAB. Well, I know angle A over here, the big angle A, angle DAB really, is 60. Let's look at it up here as a matter of fact. This is what I've got. If this angle is 60 and this one right here is 30, then I've got 2 out of 3 angles and angle 4 is the last one. So 60 plus 30 is 90. That means angle 4 must be 90. Now how else could I have done that? Well, remember, because it's a parallelogram, these two sides have to be parallel, which means angle 4 and angle 2 are alternate interior angles. They make a Z. I'm going to show you there's that Z. So angle 4 and angle 2, I could have said, oh look, alternate interior angles. That's why it's going to be the same. So that's another way I could have done that one. All right, next, angle 1. Well, angle 1 is part of this big angle DCB, which we already know is 60. So if the other part of it is 40, I can subtract 60 minus 40, and angle 1 is 20 degrees. So now I have everything I need. Angle 1 is 20. Notice that the way I like to do this is figure out everything I can about the picture first, and then come over here and look at what they're actually asking for and fill them in as I go. All right, next we're going to put some equations together on this. Number 15. These are opposite sides. Opposite sides are what? Congruent or supplementary? Congruent. So my equation would be 2x plus 8 equals 14. They're the same. What about these two? These are consecutive angles, so they should be supplementary, not congruent. 2x plus 20 would be the same as this one up here, or 3x plus 10 would be the same as this one up here. But they're next to each other, they add up to 180. That's what supplementary means. So I literally put one of them plus the other one equals 180. And last but not least, these two are equal to each other because those are opposite angles, and opposite angles will be congruent. So I'm going to go ahead and let you write the equation for that. If you need to pause and check these, or pause and do these and then check your answer, that might be a good idea. I'm also going to let you solve this one. I'll go ahead and solve this one. 2x plus 3x is 5x. 20 plus 10 is 30. They're on the same side of the equal sign, so notice I'm just putting them together, not doing anything opposite to them. Here's where I need to do opposite. I need to get rid of the 30 because I'm trying to isolate my x. So I have 5x equals 150. Then I need to get rid of the 5, and I get that x is 30. Don't forget to complete your homework, Survey Monkey. And I will see you in class tomorrow with your newfound knowledge of parallelograms. Or if you're just watching this video, maybe I'll never see you. But either way, you now know something about parallelograms.